All right, here's a tennis ball bouncing in front of a grid where the lines are spaced exactly 10 centimeters or zero point 0.1 meters apart. So what we can do from this film is we can look at where the ball is as a function of time by going frame by frame through the movie and just peeling off the XY coordinates of the ball. So for instance, if I were to choose the bottom of the ball, what we would see at this location is the ball has an X coordinate or an horizontal position of, I would say, 0.56 meters. The reason I'm saying 0.56 is 0.55 would be kind of here in the middle. We're over a little bit, so 0.56 meters for the horizontal position. And then vertically, we're at 0.8. And I would also go with 0.86, possibly 0.87 meters for the height. Able to do an analysis of the projectile motion by looking at where the ball is as we go frame by frame through the movie. What you're going to see is that each frame is 1/30th of a second apart, or 0.0333 seconds. And what you're going to want to do is, as we go through the movie, you want to choose a part of the ball, the bottom, the middle, the side. It doesn't matter as long as you're consistent and always use that part of the ball. And what you want to do is note its XY coordinates at each frame. And then what will happen is after you have that data for each frame, you'll know the X coordinate of the ball and the Y coordinate of the ball. Well, then what you're going to want to do is plot its X coordinate as a function of time, its Y coordinate as a function of time, its X velocity as a function of time, which will actually just be the change in the X coordinate divided by 1/30th of a second, and that will get you its X velocity. And then for the Y velocity, it's the change in the Y coordinates divided by 1/30th of a second, and that'll give you the Y velocity. You want to make those graphs, and you can learn quite a bit about how projectile motion works from making those plots and kind of talking about them. A little bit of a spoiler alert is that the slope of the Y velocity versus time would be the Y acceleration, or G. Now you'll see that since the ball bounces, there's going to be different little segments of motion, so you'll want to just find the slope of a particular segment. You'll see what I mean once you make the plot. Enjoy, and hope it's fun. You'll see we'll just toggle through the frames one at a time, and you just peel off the coordinates and make the plots.